Digital revolution has changed the way we work and communicate almost beyond recognition, but the smart, interconnected world that we currently live in wasn't always the same. Before the 1980s, the way in which the computers communicated wasn't standardized, so ISO came up with the OSI model, which is still being used today. This model is currently used for explaining how the data is moved in the TCP/IP protocol. Several layers are used to make up the OSI model. These are the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Let's take the flow of data and represent it with a delivery system. Sending a file or clicking a link on our computer ignites a flow of information. Each layer is represented by a person. Each box is used to represent the different data types. The first layer to receive the command is the application layer. This layer accesses the network services and contains a variety of commonly needed functions like resource sharing and device redirection. Data is packed and ready to take on a long journey. The presentation layer takes over. It formats the data to represent to the application layer, which can be viewed as the translator for the network. This layer formats the data to be understood by the following layer. The session layer rejects the data if it does not meet the requirements. The session layer is responsible for establishing, maintaining, and terminating the connection between the two devices. If the connection is correct, then the connection is established. It also remembers what data went through so that it can be recalled at a later stage. Now the transport layer takes over and it is responsible for the flow of data. A firewall is present which has the responsibility of scanning the data, and if deemed harmful, the firewall will lock onto the malicious data and destroy it. If the data is harmless, then it gets passed through to the next layer. In the network layer, the segments which contain the source and destination IP address are encapsulated with the packets. The data link layer turns the packets into frames for the network specified. It is responsible for making sure there was no error in transmission using a parity check. If there is a loss in transmission, it would request that fragment again. The physical layer turns the frames into bits, which are then sent over the network using physical hardware like an Ethernet port. Now it is passed on to the physical layer in the receiving computer to decipher the data.